Welcome to a new video and episode on my Arduino Mega2560 connected to breadboard with electronics and one piece of fischertechnik, being the switch, controlled via scientific software, mathematical software, Octave, open source. For links, see my website. By means of pulses modulation, and the objective is to not only control everything but also to acquire data. Acquiring data goes then of course that way, and I'm catching all information in vectors and matrices, because that is what you do with Octave. Last time I managed to give all matrices for data a flexible size, so they can grow now, and it doesn't stop after let's say 2 iterations of the program. One of the original objectives was to move something from within this coil inductor. However, the voltage backlash that is supposed to happen doesn't happen. So now I'm trying to figure out why, and for that I need to know the voltages to show if they are there. So I have the probes for the oscilloscope attached to the circuit, and last time it also turned out that the voltages measured are not constant. So that's a big question. How does that happen? Why does that happen? Also, question is that within the Arduino package for Octave are 2 instructions usable for measuring voltage, and they both give a different value, which is also very strange. Anyway, another thing is that by using Octave I have to load the program each and every time, so the non-volatile part with Octave, with Arduino has gone, and I hope I can restore it once I'm done with this project. But anyway, that's because of the firmware you have to upload prior to starting using Octave. That's for introduction. Let's start again and see whatever comes of it. So pressing F5 to run the program, holding the switch, and by means of this burning LED you see that everything is running, and it would be better if I show everything on screen. So I think I'll switch to screen and quit this for now. So now we start with very small thing. Let's go forward to the rest, and oh wait, see, holding the switch has led to a second one. That is not always the case if you've seen the previous episodes, so that is nice. Have I seen the other things? No, this is initialization. So let's hold them more. Oh wait, no, I have to do something else. I have to introduce time. Looking at the source code. Time is 1. However, if I look at time, then how should I proceed? Time plus 1, yes, but when I plot, it looks like nothing happened. So let's test this, keep testing this, and then I should be able to plot something. Right. Oh, and here this one is burning. So apparently I let it go right after one cycle had finished. Pressing, going. And yep. And you can't see anything until why is this signal strange? Ah, now it is good. This is a very strange signal I get. Now I get normal signals. And this is an awkward position. This is better. I want to see the LEDs. And yes, I have to hold them for a while. That's another cycle. And I can just choose when to stop, but I need some nice values. Why is one probe not doing anything? It shows absolutely nothing, which is this one. So is that really nothing, or is it just a very low value? The content of the vector will show. In the meantime, this LED, the green one, stays off. That means that the second one for the V1 remains 0. So it doesn't happen again so far. Not very surprising, but anyway. Alright, I hope that this is enough. So I'm awaiting the finishing of alright, let's quit this. Then I can release the switch and move forward. Move forward a lot. Okay, this voltage doesn't differ so much. Neither does this. These are very different. 0.5. Here difference come. Here are differences. Difference. Different. All the same voltage. Really. These are different and these are different. So look at this, coming all back. Oh, look here. 1 is okay, but how is the other one? Not okay as expected, because I didn't see the green LED. Alright, that's enough, I think. Now the question is, can I plot anything useful? Let's say V4. V4 and V41. Plot. V4, V7, and then now there's some documentation I had about plotting. Right here. Two-dimensional plots. That's more than I need. That's all I need. Right. So this should be alright. And like this would be V4 with my whole range, and then time. Actually, if this is the range, then I should put, oops, not that one, then I actually should put V7 in front. Let's see what that, if that matters. Oh yeah. And what if I do V4 first? Yeah, no, that's not good. Okay, that's, yeah. Not really sure what to think of this. What about V41? The point is now, looking at, oh wait, V7, no, I need to plot it versus time. Oh, mistake. Versus time. That doesn't show anything. That's the whole point. Literally. That's not going anywhere. There's 1 point, literally. But time is 8. Time is 8. So if I, oh, that's the whole thing, of course. If I plot it via time is, or time is 1 through 8. That's another thing. Let me try that, but I have to find out how. And then I realize that I made a mistake. This dot is indeed the correct plot. However, it's not what I want. And then I realized that I made a mistake, because these are all vectors. This isn't. This is just another value. So what I have to do is actually saying, okay, zeros, again 1.1, 1,1, that's not correct, here's a 1, and actually saying, okay, then time E is 0, going down, at least I think that is the solution, time is time plus 1. So then I would have to do everything again. But that is then another issue. What do I get? If I get time plus 1, then everything gets 1, but that is not the point. I need to get 1 through 8. So I have to test this. So I will lose all values, unfortunately. Unless I can find a solution to this that I can successfully plot. Let's say x is 1 to 8. Alright, yeah, and then plot x v4. What will give this? Ah, look at that. So let's open figure 2 and say, okay, that goes wrong. Figure 2, and then plot x against v41. Which gives this one. And now I have 6 and 61. So figure 3 and plot x v6. And yeah, I forgot. I realized that I haven't put any axis data on it. What is what, but we'll see soon enough. Then figure 4, which should be 61. Now let's go back. Which is which? Read voltage, read analog, read voltage, read analog, read voltage. Okay. So that is, so I need that one with it. V4, 41, 6 and 61. only those. Read analog pin and read voltage. That is very different. And this is also voltage and analog and voltage. Doesn't make any sense. These 3 and 4. Okay, I should actually do this. 3 and 4 and 1 and 2 should show exactly the same. Needless to say, it's not the case. There I plot the rest. Well, I should add, of course, the subplots, because now it's by hand. Yeah, that's what I'm going to do. So in the end, after the and while, I should make all subplots. Or is that even possible? That's a good question. And of course I can change it. So far I've been using while true, and I can easily change that for using here time smaller than, let's say, 9. And here I removed time, but I say now time is 1. So then I will have 8 iterations, which is nice enough. If I look here, how many iterations I do have? 2, 4, 6. Well, it will be 1 iteration extra. But that's no problem. So I don't have to interrupt anymore. And I only have to make sure that here I will say time plus is 1. So 8 iterations, and after that figure 1 subplot, and I have 7. This read pin is nice to have, but it doesn't really matter. What I'm really interested in is analog read analog read analog pin for A0, D7, or D7 and A1, and A1, A2, and yes, that's what I'm really interested in. So the other thing is, of course, that I need X is 1 to 8. Otherwise it has no use. And then X, like the other examples, X against the others. One thing though, I have to make sure that it is going to be at the right place. Okay, subplot. can do that another way, of course. Do I have subplot somewhere? Help subplot. Oh, that is going in a different direction than I thought. I have to find it out again. I did it before. Question is how. Alright. After trying out, I figured out that this is the way to go. So, 2 figures, 1 and 2, maximum of 4 plots, subplots per figure, and then here remaining 2. And I tested it with just 2 or 3 iterations, doesn't matter. Now I'm going for the full iteration, so it's a bit boring to watch, so I'll do that without it. But the most important part is that this should actually work. And yeah, I made the mistake in index value, but no problem here. Let's just run it. So, pressing and running, and there should be no problem. Alright, so that will be 8 iterations, and now I can see again that the red LED is obscured for some weird reason. Now you can see it. Okay, look at that. That is the second, that is the decrease of the pulse width modulation, which is 1. And that was shown by this LED. Very interesting. Second iteration. And no LED shown on the left side, so that one is 0 again. So the question remains, why is it mostly 0 and why is it suddenly 1? I do not have an answer. One more iteration, and it should stop automatically after 8. And then I should have some very nice graphs. Another one. So let's see how that goes. And as expected, it ended automatically. So now with so many iterations, this is, wow, okay, I didn't expect this one to happen. Wait. Oh yeah, of course. This is the whole stuff. So very nice number of values. Now the question is, this is figure 1. And the second has gone wrong. But this shows that there is quite a variation. Let's see how this one has gone wrong. 165 column 7. 65 column 7. Oh, 129 column 1. 29 column 1. Excuse me. How can that go wrong? Oh, right, wait. this is 1, 2, 3, 4. This can't be 5. If you go for 2 columns and 2 rows, you can't have a plot 5. That's the whole thing. Anyway, that's a little mistake then. How shall I solve this if I have... But... Oh wait, there's both V7. And this one can go. That's the way to go. So, I have everything. I can kill this one. Run this one separately. And there you have it. And this is, can I, yeah, this is a better view. So this is not quite what you might expect. Analog, here it is for some reason, but here they are not the same. Here there are some reason. Anyway, this is a nice way to compare them. But still questions remain. And that's all there is in time for now. That's it for now. Some graphs plotted with mysterious endings. Still don't know why the differences occur, but anyway, stop one step further towards the solution, I hope. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion, very much appreciated. You can also follow me via Instagram and Twitter. Please donate to keep my videos going on, as well as my blog, and you can donate via PayPal and Wired, which is banking. And you can also become a patron and have your name mentioned on my website, and depending on the pledge also on my with my videos. You can find everything online via my website, which is listed below. To be continued. Have a nice day and bye bye.